Welcome back. In this video, we will be discussing why we need the activation function in a neural network. Okay, the activation function, why we need. Okay, so there are mainly two things. Okay, one is it ensures or it will skews the value between some range. Okay, between certain value. Okay, for example, it may be reduce the value or use the value between -1 and the 1, or it may be if you use tan h it will be -1 and 1, or if you use sigmoid function it will be like the value will be like 0 to 1. Okay, so that is the one use of activation function, and the second one is to introduce, okay, or to bring non-linearity to the function. Non-linearity to the function, to the network or function. Okay, so about this second topic we have to discuss a little bit more. Okay, what is non-linearity or what is linearity, all those things we can discuss. Okay, consider a OR function. Okay, x1 x2, consider these are the two input. If we have like a 0 0 0 1 1 0 and 1 1. Okay, so here we can see that what will be the result. If it is 0 0, it will be, if it is OR, then it will be 0 0 will be 0, 0 1 will be 1, and 1 0 will be 1, and 1 1 will be 1. So how can you represent this in a graph? Okay, consider a x1 and x2. Consider this as x1 and this as x2. Here this is 0 0, right? And this is 1 0, and here this is 0 1. Okay, in that case let's plot this one. 0 0 will be 0, so one point will be here. 0 0 will be 0, then 0 1 will be, so this is actually 0, 0 1 will be 1, 0 1, here 0 1, this is 0 1, one point here, this is 1. Okay, then 1 0, this is 1 0, here also it is 1, then we have 1 1, right? So 1 1 may be somewhere here, here it is 1 1, the point will be 1 here. Okay, so we can see that this can be, so here we can separate 0. How many values are here? Like there are two separate values, right? One is 0 and one is 1. Okay, so this can be, we can linearly separable using a line, right? So all above the right part of this line will be 1, and all the result below this particular line or like left side of this line will be 0. So in this way we can linearly separate this particular function. Similar way we can do the AND function also. Now consider XOR function. Consider XOR function. Okay, so here also consider we have two values x1 and x2 and result as y. It will be 0 0, 0 1, 1 0 and 1 1. Here 0 0 will be 0, 1 0 will be 1, I mean 0 1 will be 1, 1 0 will be 1, and 1 1 will be 0. Try to plot this. Here we have 0, this is x1, this is 1, this is x2, here also it is 1. So we can say that 0, 0 will be 0, will be here. Okay. 0, 1 will be 1. 0, 1 will be, this is the 0, this is 0, 1. Here it will be 1. And 1, 0 will be 1. And 1, 1 will be 0. So 1, 1 will be somewhere here. Right. This is 1, 1 will be 1, 1 will be 0. Okay. So here this is 1, this is 1, here the result is 0, and here the result is 0. So here we can see that it is very hard to separate this OR function using a single line, right? For example, in the OR, what we have done, we were able to separate it using a single line, but here it is very hard, right? So if you separate, we can't do like this, or we can't do like this, right? If you draw something like this is also like very hard. Okay, so this kind of a function is called non-linear functions, or like non-linearly separable functions, and the above one is called the linearly separable functions. So here in XOR function, we cannot use a single classification model. So in this scenario, we have to use the neural network. Okay, now consider a single neural network. Okay, consider very simple network. Okay, without any activation function. Okay, consider a network. Here we have an input x1. This is w1. Okay, now here we have z. Consider bias is 0, and this is w2. Okay, so this will be the output. Consider a network something like this. Okay, so and there is no activation function. The assumption is no activation function. No activation function. And second is what we call bias is 0. Consider this scenario. Okay. Now, what is the result of here? The output can be Z2. Okay. So what will be the Z1? Here we can say that Z1 is equal to X1 W1. Okay. And what will be the Z2? Z2 will be, we can say that Z1 into W2. Okay. Now we can expand this Z1. Okay. So Z1 we know that it is X1 W1. So we can say that X1 W1 and this is W2. So this term can be a W1 W2, both are a kind of a constant. So this we can call it as a W. So here we can say that it will be W X1. So we can see that without the activation function, this again will be a linear function, right? So with this linear function, we cannot able to separate a function that is similar to XOR, right? That is non-linearly separable functions, we cannot separate it using without activation function. Okay. Now consider another example. Okay, so here we set the bias is 0, right? Now consider bias. Including the bias, how can we can see that how can we solve this? So still the activation function, there is no activation function. Okay, here we have input as x1 and w1. Here we have a bias B1, and this will be a W2, and this will be an output. This we can call bias B2. Here the result will be Z1. So we can write it as Z1. We know that Z1 will be W1 X1 plus B. What will be the Z2? The Z2 will be Z1 equal to Z1 W2 plus B2. Here we can see that Z1 can be W1 X1. Z1 will be W1 X1 plus B1, then W2 plus B2. Here we can say that W2 W1 plus into X1 plus B1 W2 plus B2. Okay, so all these are a constant, right? This term will be a constant. This we can call it as a B, and here W1 W2 will be a constant, that we can call it as a W. Okay, and here it will be W X1 plus B. So here this is again a linear function. Okay, so without activation function we cannot able to solve this non-linearity problems. Now we can just think about a complex function. Okay, consider a complex function. We can say that we have a three network called W11, W12, W13. These are the weight. W21, W22 and W23. And we have three input X1, X2, X3. And here we can say that there are two outputs Z1 and Z2. Okay. Now let me draw this network. I have three input Z1 and Z2, and we are something like here, right? Here I can say that this will be here, and this also come here, right? This is output. Here this is 1, 2. Here we can say that 1, 2 and 3. Here we can say X1, X2 and X3 here. Okay, this will be X1, X2, X3. And this will be weight W11. This will be W12. Here weight will be W21. Here it is W22, W31, W32. This will be 1, right? W11. This is W22. This is layer 2. This is layer 2, and all these are layer 1 weights. And finally we have the result Y. Okay, so this is our network, and what we are doing, we are trying to calculate its output without activation function. So we already have W11, W12, W13, W21, W22, W23 into X1, X2, X3, which will be like Z1 and Z2, right? Now consider next layer. So this is the first layer. Then consider the second layer. So in second layer we will have W11 and W22, right? So just write here second layer. We can write it as W11 into W22 into Z1, Z2. Then we will have a output like Z1, the second layer. This we can rewrite it as something like W11 into Z1, right? Plus W22 into Z2. Okay. Now, similar to our earlier example, just expand this. Okay. What is Z1? Here we can see that Z1 will be W11 into X1, W12 into X2, W13 into X3. This is just a matrix multiplication. Okay. Here I can write it as W11 will be, this is layer 2. This is layer 2 and this is layer 2. This is layer 1 and this is layer 1. W11 layer 2 will be, how can you write, expand this? We can say that W11 layer 1 into X1 into W12 X2, this is layer 2, and W13, this is layer 1, sorry, this is layer 1, W13 into X3, right? Then plus, you can say that W22 layer 2 into, what is Z2? Z2 can be W21 X1 plus W22 layer 1 X2 plus W23 layer 1 X3, right? This is the expansion of this particular formula, W11 Z1 plus W22 Z2. Now just expand this. Here we know that W11 layer 2 into W11 layer 1, right? This I will call A. So here I can say that, so when I multiply with W11 layer 2 into W11 layer 1, what we can write, let me expand this one, W11 layer 2 into W11 layer 1 into X1 plus W11 layer 2 into W12 layer 1 into X2 plus W11 layer 2 into W13 layer 1 into X3 plus, just expand this also. It will be W22 layer 2 into W21 layer 1 into X1 plus W11 layer 2 into W22 layer 1 into X2 plus W11 layer 2 into W23 layer 1 into X3, right? So I'm going to rewrite it little bit, like to make it easy, let me rewrite it. So this term will be a constant, right? W1, this will be a constant, so I can rewrite it as AX1 plus this will be BX2 plus this will be C and CX3 plus here this will be, these two terms can be called P, constant. So this will be Px1 plus this I will call it as Q. I can say that Qx2 plus this I can call it as Rx3. Again, this can be rearranged as A plus P X1 plus B plus Q X2 plus C plus R X3. Okay, so let me add one more, sorry. Let me add one more page. Okay. So again, this can be called as W1, right? This may be called as W1 X1 plus this will be another term. I can, so why I am renaming it is because this is a constant, right? B plus Q is a constant. So I can call it as W2 into X2 plus C plus R. This is another term, that is I can call it as W3, and this is X3, right? So this is the final result. This is also linear, right? So this will be, if we add like any number of neurons without activation function, will be a linear. So this will be something like this, right? This will be X1, W1, here I can say X2, W2, and X3, W3, X3, W3, and finally this will be our output. So to bring, so that is our second point. So to bring nonlinearity, we need the activation functions. Okay. So there are different activation functions are there. So we can discuss more about activation functions in our coming videos. Okay. So that is all about in this video. I believe I answered the use of activation function, and I believe it is very clear. Okay. Okay. Yeah, that's it. Thank you very much for watching my video. Bye bye.